Hello viewers, welcome to my channel IIT Olympiads and AP Physics with Ambarish, and continuing with my series of INPHO solutions after 2020's series completed. I'm starting the series on INPHO 2019. So in this video I'm presenting the problem 1, which is based on Snell's law applied to sound waves. So let's see the problem. In the lower part of Earth's atmosphere, the temperature decreases with the increase of height. Choose the origin of the coordinate system at the ground level with y-axis vertically upward and x-axis horizontal. We assume a linear decrease of temperature such that temperature at a height y from the ground level is given by Ty is equal to T0 into 1 minus By, where T0 is the temperature at the ground level. The constant B is given as 0.023 km inverse. We consider the propagation of sound in the xy plane, ignore any attenuation, reflection and diffraction of sound. Alright. So this is how the temperature is varying with height, so we can readily find out the velocity, because we know that velocity of sound is nothing but root gamma RT by m. So if temperature is given as a function of height, that means we already know the velocity as a function of height. So that's what is asked in part A. Let me read it out. If V0 is the speed of sound at ground level, obtain an expression for speed of sound Vy at height y in terms of V0 and B. So that's pretty straightforward. Just velocity is to be found. So at ground level it is root gamma r T0 by m, and at general height we just put, instead of T0 we put this value of T0 into 1 minus By. So that's what I've written here in the equation. Speed of sound Vy root gamma r T by m, and we just put a value of T as a function of y, and we get root gamma r T0 by m is V0, so V0 into under root of 1 minus By. So pretty straightforward, direct question. Then let's look at question number 2. Now what's this? Suppose sound propagates from the origin with an initial angle theta naught with the x-axis. Obtain an expression for angle theta made by the direction of propagation of sound with the horizontal at height y in terms of theta naught and b. So this question is also very similar to what we generally do in the standard theory for JEE, where we have a system of parallel slabs and we make the light ray incident on one of the slabs, and we ask what is the angle of propagation at some later slab after, let's say, n number of slabs. So this is also again a direct application of Snell's law for parallel slab system. So you know that when we have one medium and other medium and there's a boundary, so mu1 sine theta 1 is equal to mu2 sine theta. Rather, in this case I1 and I2 are the angles, so mu1 sine I1 is equal to mu2 sine I2. Now mu is nothing but C by V, so it is inversely proportional to V. So we can also say that instead of mu1 we can write 1 upon V1. So sine I1 by V1 is equal to sine I2 by V2 in this figure. Now what is sine I1 and I2? So I1 is nothing but complement of theta 1. So sine I1 can be written as cos theta 1 and sine I2 can be written as cos theta 2. So that's what I have done. So cos theta 1 by V1 is equal to cos theta 2 by V2. Alright. So that gives you, okay. So you can just say cos theta 1 by cos theta 2 is V1 by V2. Now initially the angle is theta naught, so, and we want at a general y. So what we can do, we can say that cos theta upon cos theta naught, where theta is the angle at a general y, okay, and theta naught is the angle at the at the start. So we can say cos theta by cos theta naught is Vy by V0, and Vy we just found in the previous part, we just substitute for it. Vy by V0 comes out to be under root of 1 minus By, okay. So and then we just rearrange this equation to explicitly express theta. So theta comes out to be cos inverse of cos theta naught under root of 1 minus By. Now this result we'll be using in the future part, so keep this in mind. We'll be needing this for the next part also. Theta is cos inverse of cos theta naught under root of 1 minus By. I'll state this again, but remember that it's been derived here already, okay. So now let's look at the next part. Obtain an expression for x and y coordinates of a point on the path of the propagation as a function of theta. So now x and y coordinates are to be found. So y coordinate is very simple. In the previous part we found theta as cos inverse of cos theta naught under root 1 minus By, just the previous slide. And from this we straight away get y as a function of theta. You just rearrange this equation and you can express y in terms of theta. So y comes out to be 1 by b, 1 minus cos square theta upon cos square theta naught. Alright. Now once I have y, I can find out the slope by differentiating this with respect to x. So dy by dx is tan theta, which is nothing but derivative of this expression with respect to x. So I'll differentiate both sides of this equation with respect to x. So what do I get? So if you differentiate right hand side, 1 by b is as it is, and 2 cos theta into minus of sin theta into another minus 1, that becomes 2 cos theta sin theta in the numerator, and of course there will be a d theta by dx because we are differentiating with respect to x. Alright, and cos square theta naught is a constant which stays as it is. Alright, now you see, so you have tan theta and d theta by dx. So you can bring this tan theta over here, take dx to the other side, and it's a simple differential equation. Then dx and d theta, which you can integrate directly to find out x as a function of theta, and that's what we have done. So just rearrange this equation, bring tan theta over here, integrate it from theta naught to theta and 0 to x, and if you solve this integral, finally you get this value of x as a function of theta. So I have y as a function of theta and I have x as a function of theta, and we'll see how we'll use these equations. This is the solution to part C, and this will be utilized in the next section when we are looking at the part D. So this result I'm going to use on the next slide. Okay, so let's see the next part. The next part is, for this part, assume the direction of propagation of sound to be horizontal at the origin. That means theta naught is given as 0. Okay, for the case where y is of the order 100 meter or less, obtain an approximated expression relating x and y, and obtain x for y is equal to 2 meters. Now we have to find approximate approximate relation between x and y. You know that x was some complicated function of theta and y was some complicated function of theta, but we'll see how under approximations we can find out an explicit relation between x and y. So let's see how we can go about doing this. So if y is, let us say, less than or equal to 100 meters, so we can just put y is equal to 100 meter and use our calculator to find out what's the value of theta. So if you do that, you will calculate, put the value of b and y is equal to 100. You will get the value of theta is 3 degree, which is very small. So we can use approximations for cos theta here. Now y was found to be this. This is from the previous slide. We had found the y as a function of theta. Now cos square theta, you know that it is nothing but 1 minus sin square theta. Okay, so we can convert it in terms of or we can just write it as 1 minus theta square by 2 as per the expansion of cos theta. So this can be approximately written as 1 minus theta square by 2 upon cos square. This is not 0, it's supposed to be theta naught, so I'm sorry about that. So just read it as theta naught, not 0. Okay, and this if you calculate, this is approximately, oh sorry, it's not theta naught is 0, so no problem, I'm sorry, this is cos square 0 only, because theta naught is 0. It is direction of propagation is given as horizontal at origin, so this is theta naught is 0. Okay, so if you solve this, this is 1 and 1 minus theta square by 2, and this is b outside, so 1 by b theta square. Alright, so this is y as a function of theta when theta is very, very small. And what about x? For x also, this result we had found on the previous slide when we had found x as a function of theta. In this also you substitute theta naught equal to 0. If you put theta naught equal to 0, this simplifies to x is equal to 1 by 2b 2 theta plus 2 theta. Okay, sin 2 theta can be written as 2 theta, and this is 2 theta anyway, and theta naught is 0. So this is 2 theta by b, y is 1 by b theta square. So now what do you do? Just eliminate theta from these two and you get the relation between x and y. So what do you get? X square is 4y by b. Now this is the relation between x and y, and you are supposed to evaluate x for y is equal to 2. So just plug in y equal to 2, plug in the value of b that is given in the original question, and just solve for x, and what do you get? You get x at y equal to 2 as 590 meter. Now this is our final answer to part D, and I hope you liked this video, and if you did like this video, please subscribe to my channel if you have not already subscribed, and please share it with your friends who are preparing for Olympiads, or if you are a teacher, you can share it with your fellow teachers or your students. Please share it as much as possible, and please do give it a thumbs up. And thank you all for watching this video. That's all for this video, and see you in the next one.